Hey everyone, ready to unlock the mysteries behind algorithms? Today we're diving into the Algorithm Design Manual. And don't worry, you won't need to become a coder for this.
Yeah, we're really going for that big picture understanding today.
I like that.
Yeah.
So, no coding bootcamp required for this deep dive.
Exactly.
What I find so fascinating about this book is how it uses all these war stories,
Yeah.
like real-world problems where algorithms were the heroes.
Yeah.
And get this, while the book is designed for people who might actually build these algorithms, our deep dive is all about pulling out those core concepts and seeing how they play out in our everyday lives. Because let's face it, not all of us are going to be writing code, right?
Right. And you know what's interesting is how much the world of coding has changed even since this book came out. Like, the book actually used to host the algorithms on a website because access to code was kind of limited.
Right.
But now, code is everywhere.
That's true.
It's almost like the real bottleneck isn't the code itself, it's understanding the problem you're actually trying to solve.
It's like, I don't know, having all the ingredients in front of you, but no recipe. You're
Exactly.
staring at the ingredients, but you're like, what am I supposed to do with this?
Exactly. And that's exactly where our deep dive comes in. The algorithm design manual really emphasizes that, the importance of problem modeling. You've got to get the problem right before you can even think about picking the right algorithm, right?
So, but before we even get to the how, we need to figure out the what.
Absolutely.
Yeah.
So let's take a simple example like sorting. It's something the book dives into right away. So think about having, I don't know, a jumbled up list of names or numbers, just a big ol' mess. The problem is you need to get them in order.
Right.
And that's where a sorting algorithm comes in. It
Hmm.
gives you those steps, like a set of instructions to go from that chaos to a nice organized list.
Okay, that makes sense. So instead of memorizing lines of code, it's more about thinking about different ways to sort things, like how we arrange a deck of cards or organize files on our computer.
Yes.
And some ways of doing that are obviously going to be faster than others.
Right, 100%. And that brings us to a really key concept, big O notation. Now, before you switch off, Big O isn't about, micro-optimizing every single line of code. It's more about understanding how efficient your solution will be as things scale up.
You see, this is why I always get tripped up. Big O always felt very much like, okay, this is for the hardcore programmers, you know?
And that's a really common misconception.
Is it?
Oh, yeah. It's not just about squeezing every last ounce of performance. It's about seeing the bigger picture. Think of it like, imagine you're sending out invitations to a party.
Okay.
You could handwrite each one. That would take forever, right?
No.
That's like using an algorithm that takes a really long time, like n cubed in big O terms. Or you could print them all out. Might be a little slower at first, but way faster once you're sending out like hundreds or thousands of invitations, right? That's like a more efficient algorithm. One that takes a time proportional to, say, n squared.
Okay, I think I see where you're going with this.
Yeah.
So even if printing takes a bit longer for just a handful of invitations, when we're talking huge numbers, the efficiency of that method really shines through.
Exactly. And that's what big O notation helps us do. It helps us see past those initial steps and understand how our solutions will perform when we're dealing with mountains of data.
Hi.
The kind that companies like Google work with every single day.
That's so helpful. It's like having a superpower that lets you predict which solutions will hold up, whether you're organizing a small get-together or planning a music festival.
Mm.
So big O notation, it's like having a secret decoder ring for efficiency. Starting to see that.
It is. It is.
But I have to ask, even if we're not the ones, elbow deep in code, don't algorithms get crazy complicated?
Mhm.
How deep down the rabbit hole do we actually have to go to really get it?
See, that's what's kind of cool about this whole thing.
Okay.
Even these seemingly simple algorithms, they can be surprisingly deep, right? And the book talks about this really interesting concept called the harmonic number. And now, before you worry, we're not going to go full-on math class here.
Okay, good. Because I was about to say,
But what's so interesting about this harmonic number idea is it shows how these kind of like random, at least it seems random, math concepts just pop up in unexpected places when you're analyzing these algorithms, like logarithms.
right.
It's like there's this hidden connection between the way these things work and these deeper mathematical ideas.
So it's not just about crunching the numbers. It's about understanding the why behind the numbers.
Exactly, exactly. And it's not all just, theoretical beauty. These insights, they have real world consequences, right?
Hmm.
And the book tells this great cautionary tale. It's another one of those war stories about this researcher who had access to a supercomputer
Wow.
and was, itching to unleash this power on a problem.
Okay, so you've got a supercomputer. You can probably guess where this is going.
Yeah.
Too much power, not enough planning.
Exactly. So the researcher's instinct was to just parallelize everything.
Yeah.
Throw all that computing power at the problem, just brute force it.
I mean, if you've got a supercomputer, I feel like that's kind of,
It's tempting, right?
so yeah, just hit the go faster button.
But here's the thing. Sometimes elegance beats brute force. And this war story really emphasizes that. How a really clever sequential solution actually ended up outperforming this like clunky, parallel approach that the researcher was so gung-ho about. It's a good reminder that understanding the nuances of an algorithm, its strengths, its weaknesses, that's key to choosing the right tool for the job.
So it's like having a whole bunch of fancy kitchen gadgets.
Yeah, yeah.
But not really understanding, like, when to use which one.
Right.
Right.
And that brings up a good point. Like, why does all of this matter if we're not the ones actually, down in the trenches building these algorithms? How does understanding all this actually impact our daily lives?
That's the big question, isn't it? Like, it's fun to geek out on the how it works stuff.
Yeah.
But I think for me, at least, what I really want to know is, okay, how does this knowledge actually give me, like, superpowers in my everyday life?
It's all about pattern recognition. Remember when we were talking about those sorting algorithms earlier?
Yeah.
They're not just for, organizing lists. That's like the underlying engine behind, I don't know, everything, like how databases are searched, even how you get those perfect song recommendations on Spotify.
Oh, interesting. It's all algorithms, right?
So once you start to see those, like those types of algorithms, the sorting, the searching,
Yeah.
you start to see them everywhere.
You start seeing them everywhere. It's like you're building up a mental toolkit. So when you face a new problem, you can go, oh, I bet there's an algorithmic approach that might work here. It's like that traveling salesperson problem in the book,
All right.
where it's like, find the shortest route between all these different destinations.
Like the most efficient road trip.
Exactly.
Mm.
Exactly. Like planning a delivery route or
Yeah.
something. Yeah. And that pops up everywhere, right? I remember that was something that the book really emphasized, how that problem sort of sneaks its way into all sorts of different fields.
Oh, totally. And, we might not be the ones coding those solutions ourselves.
Right.
But just knowing these different approaches are out there, it really changes how we think about problems. And that's powerful.
Totally.
And speaking of real world impact, the book talks about how a technique called dynamic programming was actually essential in making those tiny QR codes possible.
Wait, really?
Oh, yeah.
Those things are everywhere.
Everywhere.
So those tiny little squares, the things that unlock websites, they're using the same type of algorithmic thinking we're talking about.
It all comes back to algorithms.
That's wild.
Yeah. And the book talks about how, algorithms really thrive in these well-defined problems.
So it's like you're taking a big, messy problem and you're breaking it down into those smaller, more manageable steps.
Yeah.
So like you said, that's where the algorithms come in.
Exactly. Exactly. And that leads us to our final thought for today. Think about a problem you're facing right now, something that just feels big or messy, maybe overwhelming. What if you took a step back? What if you tried to define that problem a little bit more clearly? Maybe break it down into those smaller steps, just like an algorithm. You might be surprised at the solutions you discover.
I love that. It's like taking all of this knowledge, all these tools, and actually using them.
Exactly.
Well, a huge thank you to you for this deep dive into algorithms. It's been eye-opening, to say the least. I feel like I have a whole new way of looking at the digital world.
I'm glad to hear that.
And to our listeners, thank you for joining us for this deep dive into the Algorithm Design Manual. It's been a great conversation. I feel like we've only just scratched the surface. So until next time, keep those algorithms running.
And remember, stay curious.